Welcome to the channel. The peak value of the output voltage across load resistor RL is asked. So let's draw the circuit. This capacitor is C1, the diode T1. Say this is D2 diode. Say this is C2 capacitor. The input voltage sinusoidal signal is applied across 1 and 1 dash terminal. The voltage across load resistance is nothing but the voltage across 2 and 2 dash terminal. We have to find out the peak value across the 2 and 2 dash terminal. Let's see the operation. In the first case, consider during positive half cycle. So what happens during positive half cycle? Say this is peak voltage Vp. So circuit will be C1 capacitor. What about the diode D1 and D2? As we know that if the positive voltage is connected to the anode of the diode will be in forward biasing, and if the negative voltage is connected to the anode of the diode will be in reverse biasing. So if you are going to increase the voltage from 0 to peak voltage, the capacitor starts charging. Its voltage across 1 and 1 dash will be like positive and negative. Since the input starts to increase towards the positive peak, so this terminal is positive, this terminal is negative, capacitor starts charging till Vp. This operation will store the charge across the capacitor C1, that is nothing but Vp, which means that the diode T1 will be in forward biasing, means diode will be short circuited, whereas this positive voltage makes the diode D2 to go in the reverse biasing, means open circuited, and there is no charge on C2 and there is no output voltage across 2 and 2 dash terminal. Towards the peak voltage, maximum Vp voltage is stored across the capacitor C1. This is the first case. The second case, what happens if the voltage is going down towards the negative peak? Say this is Vp, say this is minus Vp. Again voltage is going towards the peak voltage. So what will happen during this period? This is 1 and 1 dash. The voltage across 1 and 1 dash now will be negative to positive. The capacitor voltage is Vp, we know that. From Vp to minus Vp once. So what happens during this operation? As the voltage changes from Vp to minus Vp, once the diode D2 goes into the forward biasing, as this voltage is negative and which is connected to the cathode of the diode will be in the forward biasing, and this diode will be off state. The circuit will be like this. Say this is 2 and this is 2 dash. So from Vp to minus Vp, capacitor C1 starts discharging and capacitor C2 starts charging. So this will be capacitor starts charging from peak value to the minus Vp, and capacitor C1 starts discharging. If the voltage, as I say, the third case, his capacitors again goes from minus Vp to Vp. So once in the same way, diode D2 will be in off state and diode D1 goes in forward in reverse biasing, and diode D1 is going into forward biasing. So diode will be short circuited and the capacitor C1 again start charging till Vp. And again for the next cycle the same thing will happening. Capacitor C1 discharges till minus Vp, and C2 charges again till minus Vp, from Vp to minus Vp. So total charge across the capacitor C2 will be 2 Vp, and we can calculate theoretically. Here, this is C1, voltage is Vp, and there is a positive and negative terminal. This is negative and this is positive terminal. This is negative and this is positive. I have to calculate the voltage across C2, say V2, VC2. I have to calculate the voltage across C2, say VC2, and that is nothing but the voltage across the terminal 2 and 2 dash. Apply KVL here. We are moving towards this side from positive to negative. Say this is negative positive, second sign is positive, so this voltage is VC2. From negative to positive, second sign is positive, so the voltage across is Vp. Coming down, the second sign is plus, and this voltage is what? Plus Vp, which is equal to 0. So after solving, what we are getting? This is plus 2 Vp. This is equal to 0. As we know that the maximum voltage across this terminal is Vp, and I'm considering the second sign, so this is plus Vp. Plus Vp and Vp, we are getting plus 2 Vp is equal to 0, and the voltage across capacitor 2, that is equal to minus 2 Vp. We are getting voltage across the capacitor C2, which is equal to minus 2 Vp, and that is nothing but the voltage across the terminal 2 and 2 dash, which is nothing but the voltage across the load resistor RL, and therefore the peak value across the resistor RL is 2 Vp. Don't consider the negative sign here. So we are getting the options like Vp by 2 root of 2 Vp and 2 Vp. Therefore, the appropriate option is 2 Vp is the peak value across the load resistor. So the third option is answer of this question. Thank you.